The popular U.S. astrophysicist Neil deGrasse Tyson warned in an interview that we will find things in space that will challenge our minds. Voyager 1 has discovered 775 unknown objects flying by in space, and they are amazing. The probe has been traveling for 45 years now, and researchers are still surprised by what Voyager 1 discovers every day. A quote from Neil deGrasse Tyson, "And once you're outside the zone, it's not clear if much will change for you, because you're kind of wandering through interstellar space at that point. And if we find something other than nothing, then that will be interesting." Voyager 1 crossed the threshold from the solar system to interstellar space in August 2012, and Neil deGrasse Tyson's words are a reminder that we know virtually nothing about that space yet. Anything we can or will find there will be a big surprise, rising from the unknown. For the first time, we are getting measurement data from a sphere that is mysterious. The interstellar medium fills the largest parts of the universe. There are such vast empty spaces between the stars that it's difficult for us to imagine the dimensions. Although scientists have spent the last few decades thinking about what this interstellar medium might look like and what it is like, it was an absolute first when Voyager 1 sent data from this space for the first time. The twin space probes, Voyager 1 and 2, have now been exploring space together for more than 40 years. Their main mission was originally to explore Jupiter and Saturn, actually, only a short mission. A unique planetary constellation prompted NASA in the mid-1970s to build two probes very quickly in order to take advantage of this once-in-a-century window to the outer planets. The position of Jupiter, Saturn, Uranus, and Neptune in the late 1970s and up to the mid-1980s only occurs every 175 years, and this unique window made it possible to send probes extremely far with a minimum of fuel. The route was calculated so that each planet the two passed would give the probes new momentum through a gravitational maneuver. The flight time to Neptune was thus reduced from 30 years to just 12 years. Voyager 1 and 2 were assembled in a rush and launched into space from Cape Canaveral Spaceport in the summer of 1977. The probes were supposed to last 5 years, and NASA worried that these two would even reach their first destination. The two probes flew so unwaveringly and carried out their mission so excellently that soon after the launch, NASA considered making the two-planet mission a four-planet mission. More than 10,000 trajectories were available for Voyager 1's visit to Jupiter, and NASA opted for a close flyby of the moon Io. For the trajectory around Saturn, Titan was chosen as another target. After Voyager 2's successful Saturn exploration, it was validly decided that the spacecraft was fit enough to fly onto Uranus. NASA applied for further funding to continue the mission and was already planning the Uranus flyby to get Voyager 2 to Neptune quickly and easily. Voyager 2 reached pale blue Uranus on January 24, 1986, photographing it for the first time and examining Uranus's moons, its magnetic field, and fine rings. Voyager 1 was already on its way to the outer edge of the solar system. The second mission objective for this probe was also clear: to reach the heliopause. This magical boundary between the end of the Sun's magnetic influence and the beginning of interstellar space is an area full of unsolved scientific mysteries. Only 3.5 years after the very first visit to Uranus, Voyager 2 reached Neptune on August 25, 1989. The deep blue gas giant appeared before the eyes of scientists for the first time in all its glory. The probe detected unusual geological activity on Neptune, found a large dark spot similar to Jupiter's red spot, and measured extremely strong winds on the surface. Today, we know that nowhere else in the solar system do storms rage as violently as on Neptune. Meanwhile, Voyager 1 was approaching the heliopause at a speed of about 520 million kilometers and on a course about 35 degrees above the ecliptic plane. On August 25, 2012, the probe flew through the outer edge of the solar system at the end of its mission to Neptune. Voyager 2 took a course at an angle of around 48 degrees above the ecliptic to also reach the edge of the solar system. At a speed of 470 million kilometers per year, it was traveling slightly slower than its identical twin. Throughout the flight, the probes measured their surroundings, scanned particles, and detected sources of ultraviolet radiation. After the final end of the main mission, NASA announced that both probes had discovered, photographed, and studied more than 775 unknown objects, features, and planets during the flybys. The mystery of interstellar space. Can you imagine a space that probably has neither a beginning nor an end, that fills billions of kilometers of distance between individual stars, and is the true mystery of the universe? Welcome to the interstellar medium. This space makes up the largest part of the universe. It seems like an empty blackness, like a nothingness that is simply there. But researchers know that this cannot be everything. This space is filled with information, the remains of exploded stars, and it's very likely that the interstellar medium also contains the structures that hold the universe together, or make it possible in the first place. The mission objective of the Voyager interstellar mission is to discover the fantastic space beyond the end of the solar system and far beyond the Sun's sphere of influence. This extended mission basically began with the flight through the heliopause boundary, the outer limits of the Sun's magnetic field. This is where the solar wind encounters the forces and radiation of interstellar space. Penetrating the heliopause boundary made it possible for the first time to measure the solar wind at the outermost edge and to investigate its interactions with the interstellar medium. Our solar system is not in a static place in the universe or within the galaxy. It is hurtling through interstellar space at an incredible speed. At the edge of our solar system, scientists hope to obtain not only measurements of fields, particles, and waves, but also information about the dynamics of the solar system's movement within the galaxy and the universe. Today, we can divide the passage of the probes into three phases: the termination shock, the heliopause exploration, and finally, the entry and exploration of interstellar space. Initially, the environment was still influenced by the Sun's magnetic field. Plasma flows from the solar winds dominated the environment. The first sign of the shift towards interstellar space was the termination shock, where the solar wind slows from supersonic to subsonic speeds and large changes in plasma flow direction and magnetic field orientation occur. The passage through the termination shock ended with the termination shock phase, and then the heliopause exploration phase began. The heliopause is the outer layer of the bubble that the Sun forms around itself with its winds. Constant streams of plasma from the Sun blow through the entire solar system as solar winds and particles. These currents envelop the Sun and its planets in a protective ball, the heliosphere. The heliopause, the outermost layer of this protective sphere, is still dominated by the Sun's magnetic field and the particles contained in the solar wind. Voyager 1 reached the heliopause in December 2004, and Voyager 2 crossed this threshold in August 2007. In this region, the influence of the Sun is increasingly fading, and interstellar space is beginning to appear. On August 25, 2012, Voyager 1 finally flew beyond the heliopause and entered interstellar space. This made the probe the first man-made object to cross this threshold. At that time, Voyager 1 was at a distance of about 122 Australian dollars or 18 billion kilometers from the Sun. The scientists were surprised that the heliopause suddenly ended as if from one moment to the next. Up to this point, they had thought that the heliopause was gently merging into the interstellar medium, but apparently, the forces from the solar winds and space formed something like a wall. At this point, Voyager 2 delivered similar measurement results on November 5, 2018, crossing the heliopause into interstellar space at a completely different point. This shows that the unexpectedly solid edge of the solar system is probably the same everywhere. Excitement in the interstellar medium. Voyager 1 has collected a wealth of data that has already dramatically changed our understanding of space. The measurement of plasma waves in interstellar space showed that the space between the stars is denser than expected. The plasma there consists of ionized gases and is a good indicator of the overall activity and dynamics of the interstellar medium. The measurements showed that the density of the interstellar plasma is about 0.05 particles per cubic centimeter, which is higher than in the outer regions of the solar system. This means that the heliopause is thinner than interstellar space. Again, researchers were astounded because nobody had expected this. The probe also measured the intensity of cosmic rays in interstellar space and, as expected, found that it's significantly higher than near the Earth. These rays consist of high-energy particles that come from various sources in the universe. The radiation from these particles would very probably be fatal for us on Earth. Our life is therefore only possible because we are enveloped by our star in a protective mantle of solar plasma streams. In 2021, there was a lot of excitement at NASA. Inexplicable data from the probe's attitude articulation and control system reported such crazy data that scientists briefly assumed that Voyager 1 had lost its mind or been abducted by aliens. The AACS is a system of gyroscopes and star sensors that determine Voyager 1's position in space and enable it to navigate safely. This data reported that the probe had lost its orientation in space. But surprisingly, the entire object was still perfectly aligned. Voyager 1's antenna always points toward Earth, and nothing had changed, so the probe wasn't spinning, and it hadn't become misaligned. The data continued to arrive safely, but they claimed that Voyager had lost its position. It took weeks to find out how this confusion had arisen. Finally, the engineers found the error. The onboard computer system had apparently switched independently, generating confusing position data, even though the probe was on course. The problem was rectified, and since then, Voyager 1 has continued its flight in the interstellar medium, unperturbed. The Voyagers have enough power and fuel to operate the main scientific instruments until at least 2025. At that time, Voyager 1 will be about 22.1 billion kilometers from the Sun, and in about 40,000 years, Voyager 1 will reach the star AC plus 793888 in the constellation Giraffe, after 1.6 light-years. Press subscribe now, because the best videos are yet to come.